If data is the fuel of machine learning, then the vector is the container it comes in. Almost everything a model ever sees is a vector. So let's build this idea carefully because it has two faces and seeing both is the key. Here is the vector 3, 2. Face 1, it is simply a list of numbers, 3 and 2. Face 2, it is an arrow starting at the origin and reaching out to the point 3 across, 2 up. A list and an arrow. The same object, two ways of seeing it, numbers for computing, arrows for intuition. The numbers inside are called components. Each one tells you how far to go along one axis. The first component, 3, is the distance along the horizontal x direction, the second, 2, along the vertical y direction. Together they pin down exactly one arrow and exactly one point. Order matters, 3, 2 is not the same as 2, 3. Now the machine learning connection. Data becomes vectors. A house might be the vector, 1,400 square feet, 3 bedrooms, 2 bathrooms. A single grayscale image is a long vector of pixel brightnesses. Each example in your dataset is one point, one arrow, living in a space of features. Our house had 3 numbers, so it lives in 3 dimensions. But real data is bigger. A small photo has thousands of pixels, a vector in thousands of dimensions. We cannot picture that, and that is fine. The beautiful thing is, the math we learn in 2 dimensions works unchanged in 1,000. The pictures are just our guide. Vectors can be combined. To add 2 vectors, you place them tip to tail, and the sum is the arrow from start to finish. Numerically, you just add the components. 2, 1 plus 1, 3 gives 3, 4. Addition moves you through space, and it is how a model nudges its way toward a better answer. You can also stretch a vector. Multiply it by a number, a scalar, and its length changes, while its direction stays the same. 2 times the vector 1, 1 becomes 2, 2, twice as long, same heading. Multiply by a negative, and it flips to point the other way. Scaling and adding are the only 2 moves in all of linear algebra. How long is a vector? Its length or magnitude comes straight from Pythagoras. For the vector 3, 2, we make a right triangle, 3 across, 2 up. The length is the square root of 3 squared plus 2 squared, the square root of 13, about 3.61. Magnitude will be how we measure size, distance, and error throughout machine learning. So, vectors. A list of numbers and an arrow in space, the same thing. Data points become vectors, we add them, scale them, and measure their length. And whether it is 2 dimensions or 10,000, the rules never change. But the single most useful thing you can do with 2 vectors is still ahead. Next, the dot product.